So, my dear students, so far we have seen analysis of combinational logic circuits under lecture 1, module 4. Now, we will be looking at design of combinational logic circuits in lecture 2 of module 4. So, what exactly that we try to do is we try to understand the design procedure. Okay, so we try to look at the description, design problem description, or we can say specifications. If we could able to interpret properly, we would be able to do the design properly. So first what we need to do is we need to understand the description. Okay, then we need to establish input output relations to a truth table for the circuit to be implemented. Okay, that is the first step of the design process. So if you look at the design steps, in these steps what exactly that we are trying to do is we are trying to find the number of inputs and number of outputs. We try to establish the input output relations, then we will obtain a simplified boolean function for each output. Then we can draw the circuit. Of course, we can verify this using a CAD tool, which is computer design tool. For example, Logisim, the Xilinx. Okay, then we can verify the correctness of the design. This is what exactly the design steps are. Now let us take an example of a design, of course, but before that let's look at the design constraints. So from truth table we obtain variety of simplified expressions, of course. Which one to choose? That means when we were trying to make a design, there may be more than one solutions. So in which case, what exactly that we try to do is which one to choose. So this purely depends on the design constraints. Say if you have a constraints on the number of gates or the amount of time it takes or the number of inputs that you're supposed to have, the number of interconnections that we are interested in, or we are, if at all you are interested in power consumption optimization or driving capability of each gate. So based on these requirements, we will be choosing one out of the possible solutions which meets your design constraints. Okay, so let us take a design example where we would like to convert a BCD number to 2421 code. So first what we try to do is we will be establishing input output relation truth table. Any design starts with a truth table input output relation. Outputs are functions of inputs. We write expression for each and every output. Here we have 4 outputs, so we will be having 4 K-maps of size 4 input because the number of inputs are 4. So I need 4 K-maps to solve this problem. So what I try to do is every time I will enter the values input output relation ABCD input X output. Okay, ABCD input Y output. So for every output I need one K-map. I will enter those values, then I'll try to simplify. I'll get an expression. That expression is expression for X. So what I try to do is I'll try to write the expression for X. Similarly, I can go for expression for Y, expression for Z. Okay, then expression for Z by entering the values of Z. Okay, then T by entering the values of T. We will take the expressions, all those expressions. From those expressions, what I try to do is I try to draw the circuit diagram. So this is the circuit diagram. This diagram is giving me what is how to get X, how to get Y, then how to get Z and T. So from this what I can say is if I give the BCD code, I'll get 2421 code as output. This is a code converter. Is it clear? If you want to check this, you can check manually. If you want to check this, you can check with a tool called Logisim. Okay, you can use various other tools, but one of the simplest tool that is possible is Logisim. Say for example 0 0 0 0 0 4 inputs. What is your output? Just check it out. Okay, so you can check the values by putting them or plugging them into these four expressions. Then you can get okay, x y z t values, which will give you 2421 code. Okay, in this way, okay, I can design a circuit. So what exactly this is? This is exactly a code converter. This is a code converter. This is a code converter, right? Input is BCD, output is 2421 code. Okay, this is a sample example where if we want to verify this, of course we can verify this manually. Or so on the whole, what exactly we did out of this lecture is we have established input output relations. Okay, problem description we have to understand. Example, say code converter. One example code converter we have seen. Output is function of inputs. Inputs to the output relation is known as truth table. Truth table is key to the design. The number of K maps is equal to number of outputs. The size of the K map depends on the number of inputs. As the number of inputs increases, the system becomes complex. Okay, so this is what exactly the thing that is with respect to design.